This is a basic introduction to how you use marble slides and some of the background information that you're going to need to know in order to be able to understand how to do these marble slides. And remember from the introductory video that the main idea is that this is a puzzle where you're trying to figure out a way to get this marble to knock out all the stars that are on the page. So if I were to click the launch button right this second, for example, I'm going to click launch and the marbles are going to fall straight down. So we need to use the line that's provided here as kind of a ramp in order to get the marble to roll where we want it to roll. And we are going to adjust this line by adjusting its corresponding equation over here to the side. And I think it's important for me to remind you exactly how this equation corresponds to what's happening on the graph. So every one of these equations is in what we call slope-intercept form. And I've just zoomed in here on the graph so you can kind of see what's happening. So the equation that's over there to the left is y equals 4x plus 3. So let's see exactly where this equation corresponds to what's happening with that line. So the equation for a line in slope-intercept form is y equals mx plus b. And let's start by talking about the b, which in this case is the number 3. So the b is the y-intercept, and the y-intercept, in case we have forgotten, because we've been off for a little bit, is wherever the line hits the y-axis. So because this is the y-axis right here, it hits right there at the number 3. So that is where the 3 comes from in the line that's graphed. Now as for the m, for those of us who don't remember because we're on vacation brain, m, which in this case is going to be 4, that number in front of the x, stands for the slope of the line. And the way that you find the slope of a line, for those of us that might have forgotten, which is totally okay, that's why you're here, right, is you just pick 2 coordinates. In this case for the line, we're going to pick 2 places where it hits in a corner. So what I mean by a corner, for example, so I don't want to choose, like, say, that right there, because that's like kind of in the middle. I want to choose this one because it hits right in a corner, and that one because that hits right in a corner. And then you're going to draw a little imaginary right triangle. Hopefully this is starting to ring a bell for some of us now. So you have your rise, which is the vertical distance between those 2 coordinates, and you're also going to have your run, which is your horizontal distance. And to find the actual slope, you take the rise, and it goes over the top of the run in the format of a ratio. So in this case, if I look at my rise, I'm just going to count. The rise is 1, 2, 3, and 4. So the rise is 4. The run, the horizontal distance, is 1. So 4 over 1 simplifies to a 4. So that is where the slope came from in this particular case. So how can we adjust this line so that we actually get the ramp that we need for this marble to hit those stars? My opinion, for what it's worth, is to look at the slope of the line of the stars. So we're going to need a ramp that basically goes like a little something like this, right? So that way the marble will be able to just roll down the ramp and it's going to knock out all those stars. So we've got an imaginary line here. Let's figure out what the equation for that line would be. So again, remember it's y equals mx plus b. So first thing I noticed from my imaginary line here is that it hits the y-axis right here at 3. So based on my equation, I don't need to change the y-intercept that was already there. Because remember, the original equation of the line, which you can't see because, of course, I zoomed in, but it's y equals 4x plus 3. It's what we have there in the box right now. So the y-intercept is good. We don't need to change that, but we obviously need to change the slope. We need to figure out a way to get it rotated so it's more down here instead. So I'm going to pick a couple of the stars. I'm going to pick that one sitting right there on top of the line, and that one is sitting right there on top of the line. And I am going to find the slope between those two coordinates. So I'm going to find my rise, which is 1, 2, and 3. And then I need to find my run, which is my horizontal distance, which is 1, 2, 3, 4, 5, and 6. So 3 over 6 simplifies to the same thing as 1/2. So all I need to do, I think anyway, is take the slope of the line that I already have, and I'm going to change it to a 1/2 instead. So let's see if that works. So I'm going to go over here to the equation editor over here in this area, and I'm just going to change that 4 to a 1/2. Sure does look like that's going to work. So now let me click launch. Bam! I did it. Our next example gives us an idea of not necessarily changing the slope or the y-intercept, but those constraints or those limits that we talked about earlier when we were learning about mazes. So if I press the launch button the way the line is right now, you notice it's going to get those first couple stars, but it's not getting those last couple of stars. So I've got to figure out a way, because it's obviously, let me show you. I think my screen might have done something goofy. I'm going to show you one more time. So see, they fall off before they get to the other two. So what is the obvious issue that needs to happen? Well, this line needs to be longer so that the marble will get to the others. But you notice that this guy right here is underneath everybody else. So if I just make the whole thing go in a straight line, we're going to miss that star underneath. So we still need to cut off the line. We just need to make it a little longer, though, so that it still gets to down here before it kind of falls off and gets this guy underneath. So we know for sure, if I'm looking here, I can tell I need to extend the line out probably to like around there. And so let's figure out how I would do that. So I don't need to change the slope. I don't need to change the y-intercept. All I need to do is make it longer. So to remind you what part of the equation tells you that, take a look over in our equation box and look at this guy right there. I'll rewrite it a little bit bigger here for you to see. With those little squigglies that I can't draw, and the x is less than 4. So what that constraint is telling the computer to do is cut off the line right here when x is equal to 4. So if we need it to extend a little bit more, make it a little bit longer, let's see, maybe about, we probably want it to get to around, I'm going to say, let's see what happens if we extend it to, so it cuts off at 8. So I'm going to change that constraint where it says x is less than 4, and I'm going to change it to where it says x is less than 8. And so that way it'll make the line longer. So let's see if it works. It didn't quite fall off in time. So that means I'm probably going to need to shorten it a little bit. So this is just kind of guessing and checking. So I'm going to try cutting it off at 7 instead. Let's see if that works. It might get there to it. Let's see. And bam, I got it. So here we go. Now we have our final example. And if I click launch the way it is right now, I'm going to get those top two, but those bottom two stars are left there hanging. literally, right? They're just kind of hanging out there. So there's a couple of things that I can tell need to happen. And first of all, I'm going to have to take this line and chop it off somehow, because that marble needs to get down here at some point, right? So let's figure out how I can do that. I can do that, of course, by making this line shorter. So right now, the constraint, I'll write it a little bit bigger so that you can see it. It says that x needs to be greater than 0. So that means that the line is starting down here at 0, and it keeps going. So we don't want that line to start at 0. We want that line to start, farther in this direction so that it cuts off that line. So let's see. Maybe if we cut it off right about here, maybe. So that means we would need to cut it off at where x is equal to 7. Okay, so let's change that constraint to x is greater than 7 instead. So now it's going to start off right there. And let's see if that's going to work. Okay, misses the mark. What happens if we make it a little bit shorter? So say we cut it off at 6 instead. Oh, oops, that's not what I meant to do. Meant to cut it off at, what I meant to do was say cut it off over here at like 8 instead. I went in the opposite direction. So let's see if that works. Okay, still got almost all of them, but not quite. So I'm going to pay attention to what these directions say now, where it says type as many equations as you need. So that is kind of a clue that maybe I'm going to need more than one line. So let's see what I could do to maybe fix that. So let me explain what I just did with a little bit of trial and error. I thought maybe it would be a good idea if this marble comes and it drops off, if it has another ramp to fall onto, and then it goes from there. So then I tried to figure out, okay, well, what exactly would that line look like? I drew an imaginary line between those two stars. I saw that the slope of those two stars, which I'm going to get by doing my rise and my run. My rise was 1, my run was 2, so that helped me to decide that I was going to type in an equation that said 1/2, and then I kind of continued my imaginary line out to see about where it would hit the y-axis for the y-intercept, and it hits it at 3, which is why I decided to do +3. So I am going to see if that works. I haven't actually tried it yet. So we're going to launch. Darn close, but not quite. So you notice that, my line is still, my blue line, it looks like it's just a little too long because it's falling off. It's a little bit too late. So let's do 8.5 maybe. Try to make it a little shorter, see if that works. Still not quite. So after a little trial and error, I thought, what would be really helpful is if I had kind of like a wall right here, so that when the marble came down, it would bump into that wall and it would force it down early. Well, we know how to make a vertical line, right? Because we've done that before when we did our mazes. So let's say I had like a little bumper wall right here, a vertical line. We all know that would be an x equals equation because that would be a vertical line. And we know that x equals whatever it goes through on the x-axis. So that would be x is equal to 8. So let me add an equation here that says x is equal to 8. I've got my vertical line. But boom, here's my problem. It's stuck, right? I'll bet you guys have an idea for how to fix it. Why don't you maybe pause the video and try that yourself and see what you think you might do? I'm going to assume that you paused the video and you tried to fix this yourself. I'm going to go ahead and tell you what I did. So I realized, okay, I probably need to cut this line off to about here so the marble goes down and comes through there. So I am going to add a constraint. I want that line to be no lower than 8. Like, I don't want it to get any lower. So that means I'm going to add the constraint y is greater than or equal to 8. That way it keeps the big line up here above the 8, but it cuts it off and gets rid of all this down here. So let's see if that works. Remember how to add a constraint. I'm going to do my squiggly bracket, and I'm going to do y is greater than 8. Close it with the bracket. Let's see if that works. Ta-da! Success. So now there is a series of marble slides activities for you to try on your own to kind of get the feel for this. There aren't hints, but you can certainly reach out to me if you feel like you need a hint as you're going, and I will definitely provide you for one. I can't wait to see what you guys do.